All right, so let's talk about the value of n, the value of the index. Okay, so if you have an even index, right? So remember the nth root is basically, we're saying that's the index, right? And so here we have an even index, and here we have an odd index. Okay, so let's talk about powers first for a second. If I do, let's just use 5 as an example. If I have 5 to the second power, I get 25, right? But if I have negative 5 to the second power, I also get 25. Okay, so there's two things you can square to get 25. And the same thing if you have, like we just talked about with the fourth power. So if you have 5 to the fourth, you would get 625. And if you have negative 5 to the fourth power, you would still get positive 625, right? And so that's where the principal root comes from, right? If you take the square root of 25, you just get 5, right? If you take the fourth root of 625, you just get positive 5. Okay, so we get the principal value. Now, let's talk about the other way around. So what if I'm taking, or let me actually keep that stuff up there for a second. So now if I want to take the root of a negative, like the square root of negative 25, and we've talked about this before, we know how to operate with it, but we know that there's no real number that we can square to get negative 25, right? And so in this case, a is the radicand, by the way. So in this case, if we have a negative radicand with the even index, there are no real nth roots, right? We can only get imaginary numbers. We pop an I out and so forth, right? So there's no real nth roots when our radicand is negative. Okay. All right. When it's equal to 0, like if you have the square root of 0, the fourth root of 0, you just get one root, right? Because positive or negative 0 is the same. 0 is neutral. So you get one nth root that way. And then if a is greater than 0, just like we saw, there's two values that could give you the answer there. Okay. But we only use the principal value, right? So so we use one principal value. One principal root, okay, which is a positive. All right. So now with odd situations, let's just take 5 again. If I do 5 cubed, I get 125. 5 times 5 times 5. If I do negative 5 cubed, I get negative 125. So with an odd power, and the same thing with fifth power, seventh power, etc., first power, right? With an odd exponent, the sign carries over, right? So if I take the cube root of 125, the only answer is just 5, right? So I don't have to worry about principal root because it's just going to come. It's going to come naturally. If I take the cube root of negative 125, it's negative 5, right? There is a number that we can cube to get negative 125. So imaginary numbers and principal roots only apply to when you have even powers, because with odd powers, it's okay to have a negative, right? Because the negative will just come out itself, right? Because you can cube a negative and you get a negative. You can't square a negative and get a negative unless it's imaginary, right? So, all right. So with odd values, with odd indices, and indices is plural for index, then you always get one root, no matter if the radicand is negative, 0, or positive. You always get just one root, okay? And the sign carries. If there's a negative inside, your answer is negative. If there's a positive inside, your answer is positive.